When? How? Who?
Is there no thumbs up?
No.
Okay. Secret sign language. Okay, we're gonna pray first, actually. So we can pray with us too. Oh gosh. Let's pray together. Bow your head, close your eyes. Dear God, dear Heavenly Father, thank you so much for bringing us through this break, God, and for giving us that moment of rest, God. Thank you for giving us that much needed sleep, God, and that moments that we could spend with our family, God. And moments that we could share time with our friends and enjoy each other's company, God, over Christmas and New Year's, God. And thank you for allowing us to celebrate in this joyful way, God. Thank you for bringing us back here safe, God. Thank you for bringing us back here happy and smiling, God, and reminding us that this is another opportunity to serve you, God, and to just remember to rejoice in this beautiful life that we live, God. To remember to be as joyful as possible in your love, God, the love that you give us, God. And I thank you for all of that, and I pray for all the students, God. I pray for all the students and all the teachers and all the administration today, God, staying for the rest of this year, God, that we do the best that we possibly can, God, that you help us to do the best job that we possibly can to serve you, God. That it's our highest aim, our highest objective. I pray all this in Jesus Christ's name. Amen. Perfect time. Oh, okay. Thank you.
Okay. Okay.
All right. So, the first part of this lesson today is fairly simple. Well, actually, like, pretty good. All right. Please take out your notes. We're on chapter 7. What is a ratio? What is a ratio? A fraction, right? Right, yeah. Good. Ratio is like if I have 3 green marbles and 12 blue marbles, then my ratio of green to blue is 3 over 12, right? Another way of writing a ratio is like this, 3 to 12, right?
Yeah.
Okay. Mostly in this class we'll be dealing with ratios in terms of actual fractions. Okay? Now, this is fairly straightforward. And I think you're going to be able to get it fairly quickly. Okay? But it's important that we understand what it is that we're doing, right? Because if I say the ratio of green marbles to blue marbles is 3 over 12, and then I say, well, I've got 9 green marbles, then how many blue marbles should I have? If the ratio of green marbles to blue marbles is 3 to 12, and now I have 9 green marbles,
21.
how many blue marbles should I have? 36. Why? Why? Yeah. Yeah. If I have 3 green marbles and 12 blue marbles, right? That's my ratio. 3 green for every 12 blue. Well, then if I have 9 green, then I must have 36 blue in order to keep the ratio the same. Now, if I simplified this ratio 3 to 12, it would be 1 to 4. Is that right? So if I simplify this, 9 over 36, what should I get?
1 over 4.
And I do, right? Divide both the top and the bottom by 9, and I get 1 over 4. Right? Cool. Now, if I say my green is 3, my blue is 12, then what's my total? How many total marbles do I have? 15, right? So what's the ratio of green marbles to total marbles? 3 over 15, or if I simplified it, it would be 1 green for out of all my marbles. If I have 5 total marbles, I would have 1 green. Does that make sense? Okay. So if I've got 27 green marbles, how many would I have in total? I made that hard. No reason. But if I have 27 green marbles, how many total marbles would I have? What am I doing mathematically? Multiplying what?
15.
My ratio of green to total is 1 to 5. So now I have 27 green. How many total should I have? How many more times do I have green marbles? 27 times more, right? So how many times more should my total be? 27 times more, right? So I should have 5 times 27, right? Does that make sense? So it ended up being 27 over 135. Right? So how many total marbles do I have? Cool. There's another way that I can do this. Okay? I can set up an equation. What if I said I have my ratio of green to total is 1 over 5, right? And I say to you, well, I've got 40 total marbles, and I want to figure out how many green marbles I have, right? Well, my ratio is green to total, right, is 1 over 5. I know I have 40 total. I don't know how many green marbles I have. I want to solve for that. What should I put here? X. Does that make sense? Maybe?
Yeah.
I don't know how many green marbles I have. I want to solve for that. So I know, but I know the ratio has to be the same, right? That's what I'm saying, right? The ratio is the same. So what does it come out to be? X over 40? Let's figure this out, right? How should I solve for X?
Yeah. Wait.
Well, I don't have to cross multiply.
It's kinda like-
I just multiply both sides by, I want to get X by itself, right? So I multiply both sides by 40. On this side, I'm left with X. On this side, I have what? 40 over 5, which is 8. Cool?
Yeah.
Make sense? Right. And then if you look at this, well, 5 times 8 is what? 40. 1 times 8 is?
Okay.
Cool?
Could you just do it like that?
Yeah. You can do it however you want, is the point. There are many ways to do this. The key is just to understand what you're doing, which is basically you're multiplying by a common factor, right? You're multiplying by the same thing. If I say I have 2 hamburgers for every 3 cheeseburgers, right? And I have 2 for every 3. And then I say to you, well, I have 8 hamburgers. How many cheeseburgers should I have? If I have 2 hamburgers for every 3 cheeseburgers, I have 8 hamburgers, I should have, oh, how did I get that?
8 divided by 2.
Right, 2 times 4 is equal to 8, right? So 3 times 4, figure out that one, right? Making sense? Right? If I have 3 red marbles for every 4 blue marbles, and I say I have 30 red marbles, how many blue marbles should I have?
40.
40. Make sense? What am I multiplying it by? 10. All right, these are ratios. Another word for ratio is proportion. Proportion. portion. Now, solving this algebraically is relatively straightforward, as I'm sure you guys can kind of see, right? If I have some kind of x or some kind of something, if I just set up an equation for you, it becomes relatively straightforward, I think, right? The new thing is calling them ratios or proportions. So let's erase all of these so we're not so scattered. Just to make sure we got it. Ratio, proportion, same deal. Let's make it visual. I have 3 red marbles. Five blue marbles. Let's say I'm creating packs of marbles, right? Because this is what I do. All right? And in one pack of marbles, I have 3 red, 5 blue, and 2 green. Okay? Now, let's say I create a certain number of packs of marbles and I end up with 55 green. Or 54 green, I apologize. 54 green, or 55 blue is what I meant to say. I have 55 blue. Where did it go?
It's right on here.
Thank you. 55 blue marbles, okay? If I have 55 blue marbles, how many green marbles should I have? How did you figure that out?
5 times 11.
Right, you figured out that the factor was what? The multiplying factor was 11. So I have 55 blue, 22 green, and how many red should I have? 33 red. Now, how many packs of marbles do I have? 11, right? That's kind of just figuring out the multiplying factor, right? I have 11 packs of marbles. All right? Cool. Good. So, I'm going to give you a series of questions and we can all come up and solve them. Yes? Just leave. Cool. Understand this?
Yeah.
All right. Very good. Now, let's see. If I know that my ratio of, let's say, x to y equals 2 to 5. Then in terms of y, what is 5x equal to? 2y. Why? If I cross multiply, I get 5x equals 2y. Very good. What about y over x? What would y over x equal? 5 over 2.
Good job.
Just simply flip the fractions, right? What about x over 2? What would that equal? Y over 5? Does that make sense, everybody? I divide both sides by 2, multiply both sides by y. I get x over 2 equals y over 5. Very good. What about if I said 5 over 2? What's 5 over 2 equal?
Y over X.
Y over x. Good. What about 10 over 4? 2y over 2x, right? Which would simplify to just y over x. Same thing, right? If 5 over 2 is y over x, then 10 over 4 is 2y over 2x. Does that make sense? Cool. What about 5 over y? What would that equal?
2 over X.
2 over x. Good. Here's a different one. What about if I have x plus y over y? Two plus 5 over 5, or 7 over 5. What about x over x plus y?
Yeah, 2 over 2 plus 5.
Is everybody getting this? You guys understanding this? Kind of? No? Yeah? A little bit? Were you having...
What are you doing? Like, okay, no, I get it. Like, I get it. I just,
What am I
is
doing
there
for
a
these
certain
last?
step that's just consistent in every single?
Not necessarily. That's why I was kind of flowing with it, and I need to be sure that you guys are all getting it. But for instance, like for this one, y over x, if I have x over y, to get y over x, I just flip the fractions, right? You just kind of have to look at it is the key. If I have x over 2, I would have to, if I want to solve for x over 2, I have to rearrange this equation, right? I have x over y equals 2 over 5, right? If I want to get x over 2, I have to multiply both sides by y and divide both sides by 2. Does that make sense? The 2's cancel out here. The y's cancel out here. I'm left with x over 2 equals y over 5. You see that? So you could do it like that, x over 2, oh, it equals y over 5, or kind of just see like, okay, bring the 2 there and the y would go up there, right? Like cross multiplication, okay? 5 over 2, if 2 over 5 is x over y, then 5 over 2 is just flipped, right? Y over x. And then if 5 over 2 is y over x, then 10 over 4 is 2y over 2x, right? And then for here, x plus y over y, if x over y equals 2 over 5, then x plus y over y would be 2 plus 5 over 5. You see? Because x corresponds to 2, y corresponds to 5. Do you see that? Okay. And if I have x over x plus y, well, x corresponds to 2, y corresponds to 5. I have 2 over 2 plus 5. Does that make more sense now?
Mm.
Good. You know, always feel free to call out and like ask a question. Sometimes it can be difficult. Now, I want to show you something too. If I rearrange this equation like this, x over 2 equals y over 5, we agree that's true, right? What if I say x over 2 plus 1 equals y over 5? Would I have to do something to this side? Plus 1. Right? Make sense? Okay. If I wanted to add these together, x over 2 and 1, what would I have to do to the 1? If I want to add two fractions, this is just 1 over 1 right now, right? If I want to add two fractions, what do I have to do? I could do the rapid fire, or I could just get it as common what? Denominator, right? So x over 2 plus what? 1 over 1 would have to turn into 2 over 2.
Why is that?
Just to add them, right? If I want to add the two fractions, I have to get them in common denominator.
Yeah, but why does it become 2 over 2?
Because I multiply the top and the bottom by 2. The reason why you can do that for the record class is, look, if, for instance, I have like 2 over 5, and I want to get it in terms of 10, I can multiply it by 2 over 2. Why? Why can't I just multiply it? If I multiply, doesn't it change that fraction? Why can't I just multiply it by 2 over 2 and not change the fraction, not change the value? Because it's 1. What's 2 divided by 2? 1. If I multiply anything by 1, what do I get? Same thing, right? So multiplying by 2 over 2 is just changing the form of it, right? It turns into 4 over 10, which if I simplified it would be 2 over 5, right? So it's the same fraction, it's just changing the form of it for whatever reason by multiplying it by the equivalent of 1. So if I want to make 1 over 1, which is just 1, look like something over 2, I have to multiply it by 2 over 2. Does that make sense? Okay. So then y over 5, what would I be adding to this? 5 over 5. Does that make sense to everybody? Just getting the common denominator. Okay. So it becomes what? X plus, if I want to add these fractions, what do I get? X plus
4, 2,
2 over
4, 2.
just 2, right? Equals y plus 5 over 5. Now, for the record class, if that's confusing to you, remember you can always do it the way that I showed you, right? X over 2 plus 1 over 1. This times this is x plus this times this is 2 over this times this is 2, right? If you don't want to get it in common denominator form, you can do it that way. Right? That's the way I showed you guys, so you can do it. Right? You guys remember that form? Right? And same thing with this. You could also have done it this way. Right? You can see why I like this better, right? It's a common denominator, and then you get confused right there. Maybe that's a 4. Here it's very straightforward. Okay, but anyway. Do you see what just happened? Look, I took this from here, and I made it into that. Right? Both are true, yes sir.
I have a question. Okay.
Yeah.
You know the cross thing that you did there? On that, why do you do it over 1 over 1 and not do 2 over 2 there?
I could do it to 2 over 2, but I'm just saying if I just wanted to add these without having to go to this step, making it a common denominator, I could have just done it this way.
So you only do that to 1 over 1, right? Not to 2 over 2?
You can do it to any fraction. If I had done it to 2 over 2, right? If I had done x over 2 plus 2 over 2, right? That would have been 2 times x, right, plus 2 times 2 all over 2 times 2, right? Which would have been 2x plus 4 over 4, right? Is there any common factor in the top? 2, so I pull a 2 out and I get what? X plus 2. And then on the bottom, it's 4, right? Can I simplify that? Get rid of the 2, right? And then what does the bottom become? 2. So this just becomes x plus 2 over 2, which is the same thing as I got before. Right? Make sense? Cool. Alright. So the whole reason I did this is to get us to this point here. Do you see that if this is true, x over 2 equals y over 5, then x plus 2 over 2 equals y plus 5 over 5? That's what we just proved. Okay? Let's go backwards and show that that's true. Okay? Let's say now I start with x plus 2 over 2 and y plus 5 over 5, right? What can I do to simplify this? Can I separate the top and the top, the x and the 2 up top here? I can. Can I separate if it was in the denominator? No. If I had 1 over x plus 3, I can't separate that, right? I can't separate them in the denominator, but in the numerator I can separate them. It becomes what? X over 2 plus 2 over 2, right? Does that make sense? I think I'm recording. Yeah, I am. Okay. X over 2 plus 2 over 2, right? Does that make sense?
Where'd you get the 2 over 2 from?
X over 2 plus 2 over 2. If I have A plus B over C, that equals A over C plus B over C. Does that make sense? Okay. Now, what I was saying before is if I have A over B plus C, that does not equal A over B plus A over C. That's not equal. You can't separate them in the bottom. You can separate them in the top. Got it? All right. So I have x over 2 plus 2 over 2. What does the right side become if I separate it? Y over 5 plus 5 over 5, right? Cool. Okay, now I have x over 2. What's 2 over 2? What's 2 divided by 2? 1. And I have y over 5. What's 5 divided by 5? 1, right? Okay, to simplify, what should I do? Subtract 1 from both sides. And what do I end up with? Which is what we started with, right? So I just showed both ways, going from here to here, and also going from here back, right? So basically what this is telling me is that if I have some ratio, x over y equals some number, like 2 over 5, then I can say x plus 2 over 2 equals y plus 5 over 5. Okay? Cool? All right. So with that, I'm going to give you guys an example. If I have w over z equals 3 over 8, then w plus 3 over 3 would equal what?
Z plus 8 over 8.
Z plus 8 over 8. Cool. Very good. Now, there are many ways to ask questions about ratios and proportions, and I've given you questions for your homework, which is going to be due on Monday. And your first test in this class is going to be not next Friday, but the Friday after that. Okay, at least that's how I have it scheduled. So we might do a quiz in between them, just to make sure you guys are feeling good. If anything, it'll be a short quiz, like 20 minutes. Just making sure you guys are on point. You know what I heard the other day? It was a good joke. Ready for this one? It's like, you know, without geometry, life would be pointless. Without words. At first, when someone said it to me, it wasn't like a Christian man. I was like, it's like, you know, actually, it's. And then I realized he was telling a joke. And so it's like, no, God is the reason. And I was like, oh, it's a joke. See, other people tell stupid jokes too, not just me. All right. So, for instance, I could tell you something like this: x over 2 equals x plus 4 over 2x plus 4 over 8. Right? I could say that. Solve it for x. How should I do this? What's my first step?
Division?
Well, I don't want to divide anything right now. How can I make it look simpler? What can I do? How? I can multiply both sides. I can do cross multiplication. You guys know what cross multiplication is?
Yeah.
Right? But the thing is that if I just multiply both sides by 8, this 2 goes away anyway, doesn't it?
Yeah.
So I don't need to multiply both sides by both numbers, right? I can just multiply both sides by 8,
Oh,
right?
Oh, yeah. Sorry.
And then I get 8 over 2 is what? 4. So it becomes 4x, right? 4x equals 2x plus 4. What do I do now? What? Subtract 2x from both sides. 2x equals 4. What do I do now? Divide by 2.
Wait,
Right?
where'd you get this 4x?
Yeah. keep it.
Because 8 over 2 is,
Oh wait, that's the 8's supposed to go where the x is?
well, it's just 8 times x
Oh,
over
because
2.
8 over 1, yeah.
Yeah, right? Exactly. Make sense?
Yeah.
Good. Good job. Okay, good question. Everybody got that? Okay. Go ahead and solve that one for y. Any ideas?
You got it.
Got it?
Stop
Wait,
it. You
What
got
do I
it.
do?
You got it.
What do I do first?
you.
Multiply both sides by
Yeah,
12,
multiply
right?
both sides.
12 over 3 is 4. So it becomes 4y equals 3y plus 6, right? What do I do now?
Minus 3y.
Minus
Y equals 6. Good job.
What's that?
What about now if I have 3 over x equals 4 over x plus 1? Hint. Cross multiply. What's cross multiplication? Let's do it. I do this times this, so I get 3 times x plus 1 equals this times this. Now, this isn't the same as the rapid fire adding fractions type of thing. It's only true when I have something over something else, a fraction equals another fraction. Then I take the bottom, multiply by the top of this one, bottom of this one, multiply by the top of this one. Okay? That makes sense? Alright? The reason why that works is this. If I have A over B equals C over D, right? First I multiply both sides by D, right? And I get dA over B equals C, right? Then I multiply both sides by B, and I get dA equals CB, which is the same thing as just doing B times A equals B times C. See? Got it? So this becomes what? 3x plus 3 equals 4x. What do I do now? Minus 3x. 3 equals 4x minus 3x is x, right? All right, 2 over y equals 4 over y plus 2. That's good. Okay. Cross multiply. 2y plus 2 equals 4y, right? This becomes 2y plus 4 equals 4y. Subtract 2y from both sides. I get 4 equals 2y. Divide both sides by 2. I get y equals 2. Got that? All right. Now, x plus 2 equals x plus 3. Okay, this one I'm going to do with you. We don't have much time left. Okay. I do the same thing. I cross multiply, right? Okay, so I do this times this times this. So I get x plus 2 times x plus 3 equals 2. Everyone got that? Yeah. Okay. You don't have to copy this down. You can look at the video if you want. Or you can copy it down if you want, but I'd rather you just pay attention for that. Or you can. Whatever you prefer. Whatever you prefer. As long as you feel like you're learning. All right? What do I do to multiply these two? FOIL, right? It becomes x squared plus 3x, right? Plus 2x plus 6, right? Equals 2. Simplify, x squared plus 5x plus 6 equals 2. What should I do with this 2?
You can move 6 to the other side.
Subtract.
Subtract 2. Why do I want to subtract the 2? Instead of get it in this form, which I know, right?
I can't see.
I apologize. I'll move in just a second. Right? That's a quadratic equation, right? X something times x squared plus, like a times x squared plus b x plus c equals 0. It's a quadratic equation. I can use quadratic equation, but I can also see, can I factor this out?
Yeah.
X squared plus 5x plus 4. What is that? X plus
2, no,
No,
3.
1 or 4.
x
Yeah,
plus
1 or 4, yeah. 4.
x plus 1 times x plus 4, right? Does that make sense? So if this equals 0, then what's x equal to? -1 and -4. Right? Cool. I know it might have been a little while since you did quadratic. I mean, we did some quadratic equation before in this class. Just factoring. Come on, you guys got this stuff. Easy peasy. Alright, good job. That's it. That's all she wrote. Signing off for the people back home.